Welcome to the 5-6 video on parallel and perpendicular lines. We have two objectives with this lesson. Number one, I can determine whether lines are parallel, perpendicular, or neither. And I can write equations of parallel and perpendicular lines. Let's start off by defining what parallel and perpendicular lines are. So if you have two distinct or two different lines in a coordinate plane, they can only do one of two things. They either intersect or they are parallel. Parallel lines in the same plane never intersect. As you go from positive infinity to negative infinity, parallel lines will never intersect, and we'll look at why that's happening in a minute. If two lines intersect, a very specific way that they could intersect is at a right angle or a 90-degree angle. And if that classification is met, then the lines are perpendicular. So perpendicular is just a subcategory of intersection. It's a very specific way two lines can intersect. So these are the only really two ways that lines can behave. They can intersect or be parallel, and if they intersect, they might intersect at a right angle, making them perpendicular. Parallel lines always have the exact same slope, and perpendicular lines always have opposite reciprocal slopes, and we'll talk about what that means in a moment. So if you look at parallel lines, and you have to kind of use your imagination here to zoom out on the graph, they're never going to intersect. And they have this property because they have the same slope. If you think about what slope means in directional terms, rise over run, this makes sense because, for example, the red line having an equation of y equals 1/2 x plus 1, and the blue line having an equation of y equals 1/2 x minus 2. If you were to plot each one of those, start at your y-intercept, 1 and -2 respectively, and then you'd go up 1 to the right 2, or down 1 to the left 1. But every time the red line goes up 1 and to the right 2, the blue line will also go up 1 and to the right 2. So they're taking the same directional shape as we go both towards the right and the left of the graph. You'll notice the line here about having different y-intercepts. Parallel lines must have different y-intercepts because if they have the same slope and the same y-intercept, well, then they're the same line. They'd be overlapping each other. And that would just be intersecting. So parallel lines must have the same slope but different y-intercepts in order to be parallel. Perpendicular lines, on the other hand, have a slope that is a product of -1. Vertical lines and horizontal lines are always perpendicular for obvious reasons. So let's look at an example here. So let's say this red line, y equals 1/2 x minus 1, has a slope of 1/2 because it's in the m spot. Blue line has a slope of -2. 1/2 and -2 are opposite reciprocals, making the lines perpendicular. You'll notice that there is not a note here about y-intercepts being different. Perpendicular lines can have the same y-intercept. That would just be where the lines intersect, which is not a problem. Because the slopes are different, having the same y-intercept won't make them the same line. Let's lean into this idea of opposite reciprocals. You might have heard the word reciprocal before. In keep, change, flip, it's the flip part of dividing fractions. So the official definition of opposite reciprocals, if two numbers have a product of -1. And remember, product is multiplication. So if you multiply two numbers and you get -1, those original two numbers are opposite reciprocals. Because perpendicular lines have opposite reciprocals, we should be able to generate the opposite reciprocal given a number. So let's start off with the number -3/4. In order to find its opposite reciprocal, and you can do these steps in either order, it doesn't matter, first find the reciprocal. -3/4, if you flip it, you'd get -4/3. And then we do the opposite part of opposite reciprocal. The opposite of -4/3 is +4/3. We can check to make sure that this is accurate because -3/4 times +4/3 is -1. So they are opposite reciprocals. If you did the steps in reverse, you'd obviously get the same thing. The opposite of -3/4 is +3/4. The reciprocal of +3/4 is 4/3. Boom, same thing. So perpendicular lines meet at a right angle, and this is actually a direct variation of the Pythagorean theorem. If we'll talk about this more next year, but basically two lines intersecting at a right angle are the legs of a right triangle. And we know it's a right triangle because it's a right angle, and you can connect them. So the nice tie back to Pythagoras. So let's write an equation of a parallel or perpendicular line. Remember that when you write a line, you have access to all three equation forms: slope-intercept, y equals mx plus b; point slope form, y minus y1 equals m times x minus x1; and standard form, ax plus by equals c. And you might need to move between them depending on the needs of the scenario. So let's say a line passes through the point 12,5 and is parallel to the graph of y equals 2/3 x minus 1. What's the equation of the line in standard form? So might seem difficult to generate. So let's just think about what we know for a second. We know that our new line is going through the point 12,5, and we know that it has a slope of 2/3. And we know that because the given line is in the form y equals 2/3 x minus 1, so that's slope-intercept form, and 2/3 is the slope. And we know parallel lines have the same slope. So if this line has a slope of 2/3, then our new line is having a slope of 2/3. So we know a point and we know the slope. Well, how are we going to write an equation in standard form? It's very difficult knowing just that information. So instead, let's write it in point slope form because we know the point and the slope. So that y minus y1 equals m times x minus x1. Let's plug in what we know. Y minus y1, y minus 5 equals m 2/3 times x minus x1, x minus 12. From here, we're just going to convert. Let's distribute the 2/3. Y minus 5 equals 2/3 x minus 8. Add 5 to both sides, and then subtract 2/3 from both sides. So now it's in that form, ax plus by equals c. Remember, we like a to be positive in a whole number, so let's multiply the entire thing by -3, and you'll get 2x minus 3y equals 9. So all we did was we used the given information to write a point-slope equation, which is usually the best way to do it because knowing parallel and perpendicular lines, you have to be knowing something about the slope. And then we converted it using our literal equation skills from point slope to really y equals mx plus b form to standard form. Let's try another one. Now it's a line that's going to pass through -4, -3, and it's perpendicular to the standard form equation, -2x plus y equals 3. So what's our new equation in slope-intercept form? Again, let's take a second to think about what we know. We know it goes through the point -4, -3, and we know that the given line, -2x plus y equals 3, is in standard form. And you'll recall that standard form equations, the slope is -a divided by b. A is -2, b is +1. So plugging into that system, we have -2 divided by 1, which is just 2 divided by 1, or 2. So the given line has a slope of 2. You could also add a 2x to both sides, and then it would be y equals mx plus b form, and then just seeing that the slope is 2. But our new line needs to be perpendicular to the given line. So if the given line has a slope of 2, our perpendicular line has a slope that's the opposite reciprocal. 2 as a fraction is 2/1. So we're going to take the reciprocal. 2/1 flipped is 1/2, and then multiply by -1 to get -1/2. So our new line goes through the point -4, -3, and has a slope of -1/2. Again, we know the point and the slope. Let's write a point-slope equation and then convert it. Y plus 3, because it's the y coordinate's -3, equals -1/2 times the quantity x plus 4, because the x value is -4. From here, we're going to convert it to slope-intercept form, y equals mx plus b. Let's distribute that 1/2, and we get y plus 3 equals -1/2 x minus 2. And then subtract 3 from both sides, y equals -1/2 x minus 5. And because all we needed to do is get into slope-intercept form, we're done here. That is the solution. Let's classify some lines. So 2 linear equations are going to be given to us, and we're going to determine if they're parallel, perpendicular, or neither. And remember, neither would just be intersecting, just not perpendicularly intersecting. So we'll look at 6 examples. You'll notice that a lot of them are already in one of the famous equation forms, and some of them are not. So we might need to do some converting to help us identify this. The only thing we care about here is slope. So point slope and slope-intercept form are going to be really helpful. Standard form a little less so, but we do know the equation -a/b is equal to slope, so we can still work with standard form. The hard ones are going to be the ones that aren't in an equation form at all. So, for example, the first one, 4y equals -5x plus 12, is not in one of the equation forms, but it's kind of close to y equals mx plus b. Let's divide both sides by 4 to get y equals negative 4/5 x plus 3. Well, now we know the slope is negative 4/5, and the other equation, y equals 4/5 x minus 8, is already in y equals mx plus b. So our slopes are negative 4/5 and positive 4/5. These are opposites, but not reciprocals. So these are not perpendicular, and they're obviously not the same number, so they are neither. They just intersect at some point. For the second one, y equals negative 3/4 x plus 7, and 4x minus 3y equals 9. First one is in y equals mx plus b form. We know the slope is negative 3/4. Second one's in standard form. Let's use that negative a over b. So your slope is negative 4 over negative 3. Negative 4 divided by negative 3 is positive 4/3. Well, the slope of the other line was negative 3/4. 4/3 and negative 3/4 are opposite reciprocals, and so these two lines must be perpendicular. For the third one, 6y equals negative x plus 6 is kind of in y equals mx plus b form, and the other one, y equals negative 1/6 x plus 6, is obviously in y equals mx plus b form. Let's take that top one and divide it by 6. Y equals negative 1/6 plus 1. Now you see that the slope for that top one is negative 1/6. The slope for the second one is also negative 1/6. These are the same number, so they must be parallel. X equals 7 and y equals negative 8. This might feel like we don't have enough information to determine if they're parallel or perpendicular or neither, but you have to remember that x equals 7 is a vertical line, and y equals negative 8 is a horizontal line, and perpendicular and horizontal and vertical lines are always perpendicular. So these must be perpendicular. For y minus 10 equals negative 2 times x plus 3, and y equals negative 1/2 times x minus 4, you'll notice that the first one's in point slope, but the second one is almost in y equals mx plus b form. If you were to distribute that negative 1/2, you get y equals negative 1/2 x plus 2. But we don't really care about that. We just need to compare the slopes. Because the first one's in point slope form, you have a slope in negative 2. Second one, you're going to have a slope in negative 1/2. And negative 2 and negative 1/2, what's going on there? Well, those are neither. They're reciprocals, but they're not opposites. They're both negative, so these are neither. For the last one, kind of gross looking, we're going to have to do some work on both of them. 2y equals 10x minus 20 is kind of slope-intercept form, and 5x minus y equals 10 is kind of standard form. Well, it is standard form. So let's take that first one, 2y equals 10x minus 20, and let's divide it by 2. So we get y equals 5x minus 10. Your slope is going to be 5. For the second one, 5x minus y equals 10, well, it's in standard form, but it's an easy fix to put it into slope-intercept form. So let's subtract 5x from both sides and then divide by negative 1 and get y equals 5x minus 10. You'll notice that these equations are actually identical, y equals 5x minus 10. So while they do have the same slope, they are not parallel because they actually intersect at every point. They are the same line, so they are neither.